Okay, welcome to our third episode on atomic structure, and we're going to look at electron configuration. And as I've said before, it's on the outside of atoms that determines how they react with other atoms. So in a sense, the outside stuff is the most important in terms of chemistry. Therefore, the electrons are on the outside, so the electron configuration is really important. Okay, so I expect you'll actually probably find this part a little bit confusing, so you might need to watch through this video a couple of times, and I would also strongly encourage you to go to this website here. There's some really good graphics to see what happens with the electron configuration and how that changes as you basically increase your atomic number and therefore increase your number of electrons. Watch through the video the first time, maybe go and have a play on that, but you might need to come back to this one more than once. So, firstly, in a neutral atom, which is what we're dealing with here, the number of protons will be equal to the number of electrons. So if we've got hydrogen with one proton here, that would have just one electron. Likewise, carbon with 6 protons will have 6 electrons, so 2 plus 4 is equal 6. It does mention ions here. I'm not going to talk about ions at this point. We'll come back to that possibly a little bit later. It might come up a couple of the questions, and I'll just talk about those as we get to them. But I just want to keep the picture a little bit simpler at the moment. I know my Year 10s last year did some stuff on ions, but we're not just going to worry about that straight away. So hopefully by now you understand that we have within an atom a nucleus that contains protons and neutrons, and it's surrounded by shells of electrons. And within those, the first shell can hold 2 electrons. The second shell can hold 8 electrons. The third shell can actually hold 18 electrons, but once we get 8 electrons in the third shell, then the fourth shell will start to fill up. And once the fourth shell has 18 electrons, the fifth shell will start to fill up, but the fourth shell can actually hold 32 electrons, although we're not going to worry so much about the fourth shell. So this second column, if you like, shows the electron configuration like we would have learnt in Year 10. So hydrogen, one proton, therefore 1 electron, just has 1 electron. Helium, 2 protons, 2 electrons. 2 electrons can fit in the first shell, so it just has 2 electrons in the first shell. When we get to lithium, 3 protons, 3 electrons, so we get 2 in the first shell, 1 in the second. And that pattern continues right through until that second shell is full with 8 electrons. Then we see now we have 3 shells at sodium with 11 protons, 11 electrons, 2 in the first, 8 in the second, and 1 in the third. That pattern continues all the way through to argon, where we have 2 in the first shell, 8 in the second, 8 in the third. Once we have 8 in the third, it's not full, but after there's 8 in the third, the fourth shell will start to fill. Potassium is 2881, and calcium is 2882. So 2 in the first, 8 in the second, 8 in the third, and 2 in the fourth. Now last year, we would only go up to 20, and there was a reason we stopped at 20, because we get something a little bit different happening after 20, but it's not all that complex. So once we get past 20, the rest of this third shell will start to fill up. So here we have 8 electrons in the third shell and 2 in the fourth. Now we go back and we have 9 in the third, 10, 11, and so on. And the third shell begins to fill up until we get down to here, krypton number 36, where we have 18 electrons in the third shell, so the third shell is full. Then pause, not to there. When we get to zinc, we have 18 in the third shell. Then after we have 18 in the third shell, that fourth shell, the rest of that fourth shell starts to fill up till we get 8 electrons here in the fourth shell. Then the fifth shell will start to fill up. So a little bit confusing, and I've highlighted a couple here, and I'm going to come back to that in a minute, so don't stress if you've seen something wrong with those. We'll come back to that later. But hopefully you see that general pattern, and as I said, if you go back to this website, you can see that on a periodic table, and that pattern makes more sense. However, what we need to be able to do this year is do what we call subshell notation. So, if you look over here, each of these shells has subshells. So the first shell only has one subshell, the S subshell, that holds 2 electrons, which is how many electrons the first shell holds. The second shell holds 8 electrons, but it has 2 subshells, an S and a P subshell. The S holds 2, the P holds 6 to give a total of 8. In the third shell, we have the S, the P and the D. 2 in the S, 6 in the P, 10 in the D to give 18 electrons in total. And the fourth shell has an S, a P, a D and an F subshell, and we can get 2 in the S subshell, 6 in the P, 10 in the D, and I've just realised that's a mistake because the F shell actually only holds 14 electrons, and if you look here, 2 plus 6 is 8, 8 plus 10 is 18, 18 plus 14 is 32. So that shows you where we fill up that shell. So sorry about that mistake. Now, that might be a little bit confusing like that, and as I said, you can go back to this website, but you can also use this picture here that sort of shows from the bottom how they fill up. So we have the S subshell, and each of these dots can hold 2 electrons. So the S subshell can hold 2. After the S fills up, the second shell starts to fill up, and the 2S fills up. Then the 2P fills up with 6 electrons. So there's 8 in total electrons in the second shell. Then the third shell fills up. Firstly the 3S, then the 3P. Then after we get 8 electrons there, so that third shell shown with the light red, we get this pinky colour, which is the fourth shell, that starts to fill up. So before the rest of the third shell fills up, the 4S fills up with 2 electrons. Then the rest of the third shell fills up. That's the 3D subshell up here, 3D. So there's 5 dots because that can hold 10 electrons. Then the 4P, and then up to the 5S. And that's as far as we need to go, both this year and next year. So that, if you like, is showing the order that those subshells fill up. You're probably a little bit confused at the moment, so see if this helps make more sense. So when we write the notation, we start off, the 1S subshell fills up. So 1 is the shell number, the big number at the front, then the letter is the subshell, and then the superscript number is the number of electrons in that subshell. So hydrogen with 1 electron, 1S1. 1 shell, 1 electron in the S subshell. Helium, 1S2. 1 shell, S subshell with 2 electrons. Then lithium, we have a full first shell, 1S2, that's the S subshell. The second shell has 1 electron in the S subshell. And we keep going till we say we get to, let's go to carbon again, we keep picking on carbon, 6 electrons, 2 in the first shell, which is the S subshell. There's 2 in the S subshell, and then there's 2 in the P subshell. So giving a total of 6. We keep getting down to neon, 1S2, 2S2, 2P6. So there's 2 in the first shell. In the second shell, the S subshell has 2 and the P has 6 to give a total of 8. So that's the same as 2, 8. And we keep following that pattern through. So let's go down to argon, 1S2, so 2 in the first shell, 2, and there is a mistake there still. I thought I fixed that up. Hang on, I'll just quickly fix this up. That should be 2S2, 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 not 2S6. So sorry about that. So let's look at argon. 1s2, so it's 2 in the first shell, 2s2, 2p6, 2 plus 6 is 8, so there's 8 in the second shell. Then 3s2, 3p6, 2 plus 6 is 8, 8 in the third shell. And that pattern keeps going through with all the subshells filling up. I'm not going to try and explain all of these more complex ones. I really want you to look at this website, and there's a little graphic at the top which looks a little bit like this, and it shows you the order of all the dots filling. Well, actually, maybe we could do this. Let's pick on one of the ones near the end. Let's pick on rubidium. My boat is actually called Rubidium. I think we've got time for this video. Yep. So let's just show with rubidium. Rubidium is element number, no, better stick with black. Rubidium is element number 37. So we need 37 electrons, and we would go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37. So that's what we needed to get to, 37. So we would have down here 1s2, then 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. Oh, I don't like going over a line with these, but I'm going to have to. So we've got 3d10, 4p6, 5s1. So that's how we do the subshell, and that's one of the hardest examples that we can do. Rubidium, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s1. So hopefully they're the same. That almost concludes. But you may have recognised that these two here are highlighted. And if you look very carefully, they don't quite follow the pattern. We don't go 4s2, 3d4, 4s2, 3d4. See how we jump 2 here and we go backwards 1. A similar thing happens here. We've gone 4s2, 3d8. We would expect this to be 4s2, 3d9. Now, the reason for these exceptions is that half-filled shells are particularly stable. So in the case of the S shell here with 1 electron, it's got half filled. So I should say actually half filled and completely full subshells are particularly stable. So here we have a half-filled shell and a half-filled shell. That's particularly stable. Here we have a half-filled shell and a full shell. So if you like, if you think of this D subshell, when there's just 1 electron in each of these subshells, that's particularly stable. So these two, if you like, are slight exceptions to the pattern. And when we look at ions later on, there's also a couple of other exceptions, but we won't worry about those now. So the reason those two are highlighted is they don't quite follow the rule, and that's just because of the half-filled shell thing. So it's a little bit hard to remember that, but hopefully if you practice doing these, by all means, as I said, practice looking at this website, go back and practice writing out these electron configurations a few times. That's all. Thank you.